The problem with soft soil in engineering construction always occur even during pre or post construction. The road embankment containing soft soil is often a challenge for all engineers to ensure the stability depending on the nature of the soil. Soft soils also have a characteristic of high compressibility, high plasticity, high sensitivity, low shear strength, and low permeability that will lead to the problem of high settlement and low bearing capacity during post-construction work. This will reduce the strength of workability and shorten the embankment lifespan. Therefore, soil with poor geotechnical properties requires improvement technique applications. For the objective, the aim of this study is propose any method of soft soil improvement method to reduce the settlement of road construction on soft soil. According to the aim of this study, the following are the objectives to be achieved for this study. The first one is to compare the result of settlement and assess pore pressure distribution of the proposed model with the unimproved soil. Second, to discuss the outcome of the result using suitable graph.
In the proposed model, there are three things needed to be highlighted, which are geometry, soil property, and also geosynthetic property. So for the first one is the geometry. Each of the material in the geometry, such as embankment, sand mat, and also clay, have their own specific height, weight, slope, and also length. In this project, the material is constructed in the plane straight with a 15 noded element. The contour consists of the value of x minimum of 0 meter, x maximum of 30 meter, y minimum of negative 20 meter, and also y maximum of 4.8 meter. The second one is the soil property. The material property that involved for the soil and embankment are general property, stiffness, and strength. The fill and the entire soil material were modeled as more column. The analysis for the embankment and sand mat were modeled as drain condition, while for the clay soil were modeled as undrained condition. The soil property can be referred by the previous study made in the 2015 by Wulandari and Tijandra. Next is the geosynthetic property. A layer of the geosynthetic is modeled and placed between the embankment and the soil layer. The length of the geosynthetic is followed same as the length of the soil, which is 30 meter. The value of the tensile element, or known as the geosynthetic stiffness, in the plastic study is known as the EA. So the geosynthetic property is followed by the previous research made by Silvanshnia 2010. So the identification is known as the geotextile PET woven, material type is elastic, and the value of the geotextile stiffness is 2500 kN per meter. In this project, there are two types of model needed to be done, which are model 1 is the embankment with the geosynthetic, and the model 2 is the embankment without the geosynthetic. All property and the geometry for the embankment and the soil layer will be maintained for both models. The assessment of both models should be observed and evaluated in terms of the settlement effect and pore pressure.
Proceed to the methodology, where the procedure of the whole project. So it start with the reviewing all of the previous research, and then design and properties will be extract from the previous research to be substituted in the numerical modeling, which is Plexi Study. So there are two models to be simulated in the Plexi Study software, which are models of soil without geotextile and also models of soil with geotextile. So there are 5 stage or phase in this places. First, we're defining the soil stratigraphy, and then proceed to where we apply the structure, and then mesh the wall model, and then determine the flow condition, and also lastly is stage construction, and then we can obtain the result and discussion. For the first stage, which is project properties and soil stage, or defining soil stage. So the project properties is set up in this phase, where we determine the model, which is plane strain, 15 noded element, and then determine the contour. And then this parameter also set for each material, such as for fill, sand mat, and also clay. Move on to the structure stage. where we create the embankment fill. There are 2 layers of embankment fill by using the create soil polygons, and also we create the geotextile for soft soil with geotextile model by using create geocrete. Proceed to the meshing stage where mesh all of the model, which is for the mesh option we use medium element distribution, and this is the discretization of soft soil model. We'll move on to the flow condition where we determine the boundary condition. So there are 2 parts of the condition that are important, which is deformation and also groundwater flow. So other than that, we have to determine the groundwater table where it must be on the ground surface 0 meter, and then proceed to the last stage, which is stage construction, where we aiding in the stage of phase, which is the initial phase is for soft soil and sand mat, and then top up with the first layer of fill, and then need to undergo the consolidation phase, and then top up with the second layer, and then need to be proceed with the consolidation phase. So this is the last stage, and then proceed to the result and outcome. So these are the outcome for this model, which is the settlement value of soft soil model with and without geotextile, and also access for water pressure value for soft soil model.
For the result and discussion of settlement of soft soil, okay, both figures shows that the result of settlement behavior underneath the soft soil with and without geotextile. According to Places study, okay, there are 3 points were selected during designing this. First point is point A, which is located at the starting point of embankment. Point B, located at the middle under the embankment, and the last one, which is the point C, located at the end of the embankment. Okay, for the input result with and without geotextiles, the point A and B shows rapidly settled when first and second layer of the embankment fill were applied. Okay, for the point A at the starting point of under embankment, the result in higher settlement than point B and C. Settlement at point A for model of soft soil with geotextiles is lower than without geotextile. Okay, for the next result and discussion is about the excess pore water pressure on soft soil. Okay, soft soil with and without geotextile under excess pore water pressure also have been simulated in Places study, which is using the same settlement using 3 coordinates that have been selected, which is at the point K, L, and M. Okay, in both result with and without geotextile, point K result in higher excess pore water pressure when applied the first and second layer of embankment fill than point L and M. The result is also indicates that the excess pore water pressure a bit decreases when applying geotextile. Comparison of result. Geotextile that have been shown to decrease settlement in any type of soil, even soft soil. Okay, the separation function of geotextile is essential when it is applied between 2 different types of soil. Okay, the main objective of this type of geotextile is to keep soil from mixing when water enters the soil layer. A geotextile filter should be considered as a filtering zone that evolve over time. The pore pressure requirement means that the presence of the geotextile filter should not increase the pore water pressure in the soil in comparison to the case performed without a filter.
The conclusion. By using Places study software, we have analyzed the difference in settlement and excess pore pressure distribution for soft soil road embankment with and without geotextile. The result revealed that the settlement for soft soil without geotextile is higher compared to the soft soil with geotextile. Similarly, the maximum excess pore water pressure for soft soil without geotextile is higher than the maximum excess pore water pressure for soft soil with geotextile. Soft soil with geotextile is more effective for road embankment improvement. Geotextile can help prevent settlement and excessive pore pressure by separating hard soil from soft soil. Excess pore pressure causes lesser settlement. For the recommendation, various on-site methods available in improved compressible soil. The shear strength of in situ soil must be increased to reduce settlement and improve embankment stability. Suitable ground improvement techniques include by using PVD, prefabricated vertical drain, and by using both geotextile and geogrid together, which can help stabilize soft soil.